let us discuss about mass of a lamina. Lamina is a two-dimensional plane region. If its composition is uniform throughout the lamina, it is called homogeneous lamina. Otherwise, inhomogeneous lamina. The density of the lamina equal to mass per unit area. So, we have mass equal to area A into density delta. Density delta. Okay, so we have M equal to A delta. From that, delta is equal to M divided by A. For a inhomogeneous lamina, the density is varying from point to point. So, density at a point xy is denoted by delta xy. So, delta xy is the density function. Density function. If a lamina with a continuous density function delta xy occupies a region R in the xy plane, then its total mass M equal to double integral over R delta of xy dA. So you write one problem. Question. A triangular lamina with vertices 0, 0, 0, 1 and 1, 0 has density function delta xy is equal to xy. Find its total mass. Find its total mass. Find its total mass. Okay. So, before finding the mass, we can draw the lamina here. So, you can draw the x-axis, y-axis, then we can mark the corresponding point 0, 0, 0, 1, 1, 0, 4, okay. Now we can mark this point as 0, 0. And this is the point 1, 0 and this is the point 0, 1. Okay. Now here we can mark this point as O, this point as A, this point as B. Now you can find the equation of AB using two-point formula. Now, if you know the end points, two end points of a line segment, you can find the equation of that line segment by the formula y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. Okay. Now, you substitute these values here. So, here what is y? Y is y minus y1. y1 is a to b. You can consider a to b. So, what is y1? y1 is 0. What is y2? y2 is 1. And what is x1? x1 is 1 and x2 is 0. So, you have y is equal to, x minus 1 by minus 1. So, you can write minus 1 plus 1. That means x plus y equal to 1. So the equation of this line is x plus y equal to 1. Okay. So this is x plus y equal to 1. Now you can mark the region now. The shaded portion is our required region, that is our lamina. Now we can write the formula for finding mass of the lamina. Now mass of the lamina is equal to double integral over r delta xy dA. Okay, now that is same as double integral over r. Now delta xy is given as xy, so xy dA. Now this is double integral xy. Now you can consider this region as type 1 or type 2 region. Now if you are writing dy dx, it is type 1 region, and in that case you have to draw a vertical line for finding the limit of integration. Okay, so at first we have to find the y limit of integration. So what is the y limit of integration here? So here you can see that the lower limit of here, that line touches here and here. So for finding the lower limit of y, is meeting with the x-axis, and equation of x-axis is y0. So lower limit of y is 0. Now what is the upper limit of y here? This point join with the line x plus y equal to 1. From that you have y equal to 1 minus x. So that is the upper limit of y. So here you can write from 0 to 1 minus x. Similarly, you can find the lower limit of x and upper limit of x. Now you can slowly move this line to the left side. That line can move only up to our y-axis, and equation of y-axis is x0. So lower limit of x is 0. Now you move this line to the right side. That line can move only up to this point, and that point denote x is equal to 1. Okay. So here x varying from 0 to 1. Now for finding the mass, it is enough to integrate this. Okay. Now that is equal to integral 0 to 1. Now first here we can integrate with respect to y. Okay, so x is a constant, so x into, now integral y is y square by 2, and that is from 0 to 1 minus x dx. Now this is equal to 1 by 2 integral from 0 to 1. Then you have to put y as 1 minus x. So 1 minus x the whole square, then 0 square. So this is equal to 1 minus x the whole square into dx only. Now this is equal to 1 by 2 into, now you can integrate this. Okay, here 1x is there. So this is integral from 0 to 1 x into. Now you can expand this using a minus b the whole square. So 1 minus 2x plus x square into dx. Now this is in 1 by 2 integral from 0 to 1 x minus 2x square plus x cube dx. Okay. Now that is equal to 1 by 2. Now integral x is x square by 2 minus 2 into integral x square is x cube by 3. Then integral x cube is x raised to 4 by 4, and that is from 0 to 1. Okay. Now, that is equal to 1 by 2, then 1 by 2 minus 2 by 3 plus 1 by 4. So this is equal to 1 by 2 into 1 by 12. So this is equal to 1 by 24 unit of mass. Okay, so the answer is 1 by 24. Okay. Now thank you all.